this podcast, we're going to go over what an amine is. We're also going to talk about how amines are used in medicine and how to classify amines as well. All right, as you have already learned, amines are a group of organic compounds that have nitrogen in them. So they are considered to be derivatives of ammonia, which is NH3, and due to the number of valence electrons on ammonia, which is 5, nitrogen can make 3 different bonds. So we expect an amine to have 3 different bonds attached to that nitrogen. In a couple slides, we'll talk about this in more detail, but amines are oftentimes used in medicine as decongestants as well as sedatives. And we can classify them similar to how we classified carbons and alcohols as being primary, secondary, or tertiary. Obviously, we couldn't do a quaternary because nitrogen only makes 3 bonds. All right, so primary amine is going to be a nitrogen bonded to one other group. So here we have a nitrogen bonded to one group or 2 hydrogens, and the exception to this is going to be ammonia, where you don't actually have, and this one's ammonia, you don't actually have an alkyl group that it's bonded to, but that would still be considered primary as well. Secondary amines, your nitrogen atom is going to be attached to 2 groups. So here we see 2 groups attached to the to the amine, or you have 1 hydrogen attached to the nitrogen. Oftentimes we will write these in condensed structural formulas like you're seeing here, with the assumption that you have a methyl group, a hydrogen, and another methyl group attached to that nitrogen to make your 3 bonds. Finally, a tertiary amine is where your nitrogen is attached to 3 different groups or 0 hydrogens, which we see here. Sometimes, especially when we think about ammonia, I think it's easier to look at the number of hydrogens that are attached to your amine. So this could be 2 to 3 hydrogens, 1 hydrogen, or 0 hydrogens. There are 3 different classifications that you're going to come across when it comes to amines. And the first is an aliphatic amine, and that's where your nitrogen is only bonded to alkyl groups. So you can see in this tertiary amine, we only have carbons and hydrogens or alkyl groups bonded to our nitrogen. And they don't have to be the same groups. They can all be different lengths. They can be any length, really, as long as they're just carbons and hydrogens. The next type of amine is an aromatic amine, and this is where you have a nitrogen bonded to an aromatic ring. So here we see aniline. So we're going to start to see aniline as being a parent group for your amines when you're naming again. Just be aware that that's coming back up again. And finally, we have a heterocyclic amine. And heterocyclic amines simply mean that you have a nitrogen as part of your ring structure. So instead of having a carbon, you have a nitrogen instead. This specific heterocyclic amine is piperidine. And this is found in peppers. We're going to talk more about this in class and some of the other interesting heterocyclic amines. Your book will focus on asking you a lot of questions about naming heterocyclic amines. Don't worry so much about that. Get through those problems. We are going to worry more about heterocyclic amines when we talk about DNA, because DNA has heterocyclic nitrogenous bases. So we'll see it again then. Right, so here are some amines that are used in both over-the-counter and prescription drugs. All of these drugs, you'll notice they have HCl attached to them, or they have hydrochloride in the name. The reason that they have HCl or hydrochloride in them is because the drugs by themselves aren't going to be water soluble. So instead of selling them as they are, we're going to sell them as their ammonium salts. And as you remember from lab and pretty much the last unit, anytime we make something into a salt, we're going to increase its water solubility, which is good for people because people are mostly water. So you want the drug to be able to travel through the bloodstream, which is mostly water. Our first drug is Benadryl, or diphenhydramine hydrochloride. This is used as a antihistamine. It blocks your allergic response. So if you're having an acute allergic reaction to, say, a food or a bug bite, Benadryl is going to block the histamine from getting to your receptors in your body. Methadone is our next one. Methadone hydrochloride is a narcotic analgesic. This is given as a substitute for heroin addicts. It's also used for long-acting chronic pain as well. It's prescribed for both of those, but it is prescription only. Phenylephrine hydrochloride, or better known as Sudafed PE, is used as a decongestant. So you might take this if you have a cold, if you're having congestion. All right, let's talk about histidine and histamine. Histamine is biologically active, and it's an amine that is formed from the amino acid histidine. So histidine is converted into histamine in the body. And histamine is a neurotransmitter, and typically it's going to bind to two different types of receptors in the body. It's going to bind to the H1 receptor as well as the H2 receptor. And so these are going to provide a range of different physiological effects within the body. So when histamine is present, you are going to get binding to the H1 and H2 receptors, and it's essentially going to look like your typical allergic response. You are going to get vasodilation. And vasodilation is going to be an opening of your capillaries, and what this is going to do is increase blood flow. You would see this typically if you have an infection or an injury or an allergic response to something. Other symptoms you're going to get when there is histamine binding to H1 and H2 receptors, you're going to see runny nose, watery eyes, overall redness. Remember that redness is a result of the vasodilation, that increase in blood flow. In your stomach, when you have histamine present, you're going to get an increase in acid secretion. All right, so let's talk about antihistamines. Antihistamines are going to bind to your H1 receptor. And when I'm talking about antihistamines, I'm thinking of like Benadryl. That is going to inhibit vasodilation. So it prevents the vasodilation from happening, is going to help prevent that allergic response that you're getting. Think about when you have allergies or you have cold symptoms and you take a Benadryl, it's going to dry up your nose, it's going to cause that redness to go away, or if you're having an allergic response, your hives go away. And Benadryl, any of these medications that are binding to your H1 receptor like Benadryl, these are kind of our old school amines for treating the allergic response, they are going to be able to cross the blood-brain barrier and bind with your H1 receptors in the central nervous system. Because it can cross the blood-brain barrier and bind with H1 receptors in your central nervous system, you're going to get more drowsiness. Nowadays, we have drugs like Allegra that do the same thing. They're going to bind to your H1 receptors, but they do not cross the blood-brain barrier. So they're only going to prevent vasodilation within the body, but not binding with those H1 cells in the central nervous system, and therefore, you don't get drowsy when you take Allegra. We also have drugs that bind specifically to the H2 receptor. I'm the name of my drug. Cimetidine, also known by the trade name Tagamet, is used as an anti-ulcer medication. So it's going to bind to your H2 receptor, which causes a reduction in acid secretion. So this particular drug is given as an anti-ulcer drug. So it's going to prevent the excess stomach acid secretion and hopefully heal up the damage that's been done, resulting in an ulcer in the stomach.